Welcome to All This Math. This is Professor Parker, and today we're going to discuss synthetic division. Synthetic division. Synthetic division is a way of dividing polynomials that does not require as much effort as the traditional standard polynomial long division. All right. At another time, I'm going to do another video on polynomial long division, but typically in your Algebra 2 courses or your pre-calculus courses, your teacher will introduce polynomial long division to you, which is very similar to the type of long division that you probably learned in elementary school. And then after that, once you develop an appreciation for long division of polynomials, then he or she will hit you with the synthetic division. But the thing about synthetic division is that it doesn't work with all divisors. Of course, in any division problem, the first term or the first number, in this case, we're dealing with polynomials, so we're talking about expressions. The first expression is called your dividend, right? Right? You know what I'm saying? So that's your dividend. The second expression is called your divisor. All right? Just so we are clear with the terminology that I might throw at you, right? But synthetic division only works when you have a binomial, right? One term, two terms, and the variable has a coefficient of 1. If you don't have a binomial and you don't have a variable with a coefficient of 1, then we can't use synthetic division. But in these two examples, we do have a divisor that is a binomial and the variable does have a coefficient of 1. Now, how do I know it's a coefficient of 1? I know that because there's no number written in front of the x. And whenever there's no number written in front of the variable, whatever it may be, any letter of the alphabet or any symbol, we understand that that means that it has a coefficient of 1, because that basically just means that there's one of them. So, how do we set this problem up using synthetic division? First thing you want to do is, I'm going to take the cap off the marker first, but you want to do is you want to draw a big L. Whenever I do this, I always think of DJ Premier saying "Big L, rest in peace" on the beginning of the full clip off that Gangstar album. But yeah, so you want to do this. You want to draw a big L. That looks like that. All right? You want to draw a big L. Some textbooks do it different. Like, they flip it a little different. Some textbooks do like this. They draw a small backwards L. And then they put this number right here in this space, or the opposite of this number right here in this space. But I prefer using the big L. All right? Now, basically, you're going to set up like a diagram with numbers. And it's going to be like a puzzle that we're going to fill in. A lot of things we do in algebra, a lot of things we do in trigonometry, and any math course are really just puzzles. Because if you start to really understand mathematics, you start to understand that math is really a science of patterns. And once you understand the patterns and understand what you're supposed to do in each problem, things start to look familiar to you. And that's when the work really gets easy. But of course, that only comes when you do a lot of problems. It's just like with video games. You start playing a video game a whole lot, you start to know, okay, what's going to happen when you get to this level? What's going to happen when this person does this? What's going to happen, when this level, that level, whatever, no matter what the video game is, on what system. Once you start to recognize the patterns, things start to get a little easier. Math is the same way. All right, so number one, you first look at your divisor. You look at the number in your divisor. In this case, we have a -3. You always take the opposite of that number. So the opposite of -3 is +3. So you take +3 and you write it outside of the big L. This marker's on its last leg, but we're going to rock out with it, all right, for these two problems. So this is a +3 that's outside because it's the opposite of the -3. All right, so you got -3 right here. The opposite is +3. You always do that. No matter what number is right here, you take the opposite of it and you write it out here. Then you're going to have a row of numbers inside the big L. All right, a row of numbers. Now, where do these numbers come from? They come from your dividend. Okay, so you look at your exponents, you make sure they're in descending order. 3, 2, 1. Again, no exponent written, that means 1. This is a constant, so it has no exponent. Well, it has no variable. Or you can think of it as having x to the 0 power next to it, because x to the 0 power equals 1 anyway. So you could think of 9 as 9x to the 0 power. You could do that. And then that kind of satisfies this whole idea of our exponents being in descending order. 3, 2, 1, 0. All right. Then you take the coefficients from these four terms. And if you thought of 9 as 9x to the 0, then 9, in fact, would be a coefficient in that situation. You just take them and just write them down on the top row. So you got your 2, leave a little space in between. Then you got your 5, then you got -6, then you got 9 right there. And then you're just going to do 2 steps through the whole problem. You're going to add vertically and multiply diagonally. Add vertically and multiply diagonally. Add vertically and multiply diagonally. Add vertically, multiply diagonally. All right. Let's see. Straight up and down. Boom. Diagonally. Okay. Now, so what does that mean? I start with this 2. There is no number written here. So you're going to do 2 plus nothing. 2 plus nothing, of course, is 2. And then we're going to multiply diagonally. So I multiply this 3 by this 2 diagonally. 3 times 2 is 6. Now, what do I do with the 6? You write the 6 in the next column underneath of this 5. And then we repeat the steps over again. Now we go back to add vertically. 5 plus 6 is 11. Right? And then we're going to multiply diagonally. 3 times 11, 33. We're going to put the 33 right here. And then we have -6 plus 33. We add those. What's -6 plus 33? It's going to give you positive 27. Now, 3, now we multiply diagonally. 3 times 27. 3 times 27 is going to be, let's see, 3 times 20 is 60. 3 times 7 is 21. 60 plus 21 is 81. And then we're going to add vertically. 9 plus 81 is going to be 90. 9 plus 81 is going to be 90. Now, this is how we write our answer. We look at the original dividend and we ask ourselves, what was the biggest exponent in our original dividend? In our original dividend, the biggest exponent was a 3. Our quotient from our division, the biggest exponent should be 1 degree less. 1 degree less. So all that means is, if your biggest exponent in the dividend was 3, the biggest exponent in your quotient should be 2, because 2 is 1 less than 3. And these numbers are your coefficients, right? This last number is not. This last number is always the remainder. The first numbers, whether it's 3 numbers, 4 numbers, 5 numbers, are your coefficients of your new terms. So look at this. You're going to have 2x, not to the third power, but to the second power. Then we're going to have 11, and it's positive, so you put plus 11x to the first power. And then you have plus 27, right? There are no more x's, because you were at the second power, first power, and x to the 0 power, right? Which you don't need to write, because x to the 0 power is the same thing as 1, right? And then you have a remainder. So the way you write your remainder, the technical way to write it is kind of like a mixed numeral. The remainder is part of a fraction. The remainder is your numerator, and your denominator was the original divisor. Now this 90 is positive, so you're going to write plus 90 divided by x minus 3. And this is the answer, or this is the quotient to number 1. So 2x to the third divided by 5x squared minus 6x plus 9 divided by x minus 3 is equal to 2x squared plus 11x plus 27 plus 90 divided by x minus 3. All right, so that tells us that x minus 3 does not divide evenly into 2x cubed plus 5x squared minus 6x plus 9 because it has a remainder. All right, now let's look at number 2. And I'm going to switch my marker up because this marker is done. Let's take it to the blue. All right, now, but just remember, add vertically, multiply diagonally. Add vertically, multiply diagonally. That's what we do with synthetic division. 2. This is our dividend. This is our divisor. We have a binomial. We have a variable with a coefficient of 1. So we can use synthetic division. You do your big L. In this divisor, your constant is 1. Or your second term, which is a number, is 1. So what number do I put outside the L? The opposite of positive 1, which is negative 1. Always remember, put the opposite number, negative 1. Then inside the big L, you write down the coefficients of all the terms inside the dividend. So I start with a 2, leave some space. I write a 7, leave some space. I write a 14, leave some space. I write a 9. And once again, if you're wondering why I call 9 a coefficient and it doesn't have an x next to it, it's because there's an invisible x to the 0 power. We could think of it like that, as an invisible x to the 0 power, because x to the 0 power equals 1 anyway. I should have wrote that. So that really becomes 9 times 1, and 9 times 1 is just 9. So we can think of 9 as a coefficient. And we have the coefficients of all 4 of these terms written across the top row inside the big L. So then we go here, add vertically, multiply diagonally. Add vertically, multiply diagonally. So I have 2 plus nothing, just like in the last example. 2 plus nothing is 2. And then I multiply diagonal. Negative 1 times 2 is negative 2. Where do I put the negative 2? In the next column. And then I just follow the pattern. And I just rock out. 7 plus negative 2. Now, you can think of this as just 7 minus 2. Because adding a negative is the same thing as doing subtraction anyway. 7 minus 2 is 5. 7 plus negative 2 is 5. Then you multiply diagonally. Negative 1 times 5. Negative 5. Where does it go? It goes right here. Then 14 minus 5, or 14 plus negative 5, is 9. And the reason I want to point that out is because if I sit here and I say, okay, well, I'm going to do 14 minus 5, that gives me 9. If you're sitting somewhere, sitting at home watching this, you might be like, whoa, hold up, Mr. Parker. I thought you said you had to add those. And I did say that. I did say, because like right here, I said 2 plus nothing. I didn't say 2 minus anything, but think about it. What if I did say 2 minus 0? I still would have got 2. But just understand that adding a negative is the same thing as doing subtraction. It's the same exact thing. So 14 minus 5 is 9. Then I do my multiplication. I got negative 1 times 9, which is negative 9. That goes right here. And then 9 minus 9 is 0. So now I got a remainder. Hold on 1 second. I got to go to the door. All right, I'm back. I apologize for the interruption, but I think that was the mailman. He's about to deliver my son's crib. All right. So anyway, I'm back. Last step, where were we? We were at 9 plus negative 9, which is 0. All right. So that tells us what? I told you in the last problem that the remainder is the last number in the row. Okay? Last number in the row is the remainder. Okay? So now we go back to your dividend. What was the biggest exponent in the dividend? It was 3, right? So now we know that in our quotient, right, we're going to have the biggest exponent is going to be 1 less than the biggest one in the dividend. So we're going to have 2x to the second power, and that's positive 5. So it's going to be plus 5x to the first power. And they go in descending order. That's a 2, that's a 1, and this is going to be 9x to the 0 power, which is just 9. And then your remainder is 0. So if your remainder is 0, that essentially means there is no remainder. So we don't have to worry about doing what we did in the last problem with the fraction and everything. We don't have to do that. So this will be our answer. 2x squared plus 5x plus 9 is the quotient. So what that means is that x plus 1 actually divides evenly into 2x cubed plus 7x squared plus 14x plus 9. You know what I'm saying? So like I said, this is a more simplistic way of doing long division with polynomials, but it doesn't work all the time. Like, for example, if this had been 3x minus 3 or 4x minus 3, we wouldn't be able to use polynomial, or we wouldn't be able to use synthetic division, right? We can only use synthetic division in certain situations. However, when we can use it, we should, because we want to work smarter, not harder, all right? But I'm going to do a video at some point on polynomial long division, all right? Because that works in all situations, okay? All right, so I want to thank you for tuning in, and I want to thank you for bearing with me while I had to step off for a minute and go answer the door. Please continue to send your problem, continue to tune in, and continue to send your problems into the All This Math DM, and your problem might make it to this board. Peace.